Next one is called longest valid parentheses. We are given a string containing just the character open brackets and closing brackets, and we have to return the length of the longest valid well-formed parenthesis substring. So we are trying to find a subset across a specific configuration that yields the longest. So we are kind of optimizing for the longest substring that fulfills some kind of criteria. In this case, it's a well-formed parenthesis substring. So in the first example, basically the last two parentheses form a well-formed substring because we have the equal amount of closing and opening brackets, and they are in the right order. So we have an opening one and then immediately a closing one. Next, we have the example 2, and basically the four middle parentheses are creating a string of size 4, which we return because that's the maximum, the longest substring of well-formed parentheses, because we have one open, one close, and then one open and one close. For the example 3, we just have an empty string, so we just return 0. The string length is from 0 to 3 times 10 to the 4th, and also the elements, as we said in the problem description, the elements of the string, the characters of the string, are only open and close parentheses or brackets. Now, to solve this problem, we already said that we are maximizing for the specific configuration a substring in this case. So we are only choosing some elements from the original string, and the criteria is that we have to have a well-formed parentheses. Basically, this hints us to the maximization problem in the DP by keeping track of a well-formed parentheses. Now, to solve this, solve the problem, basically we have to, each time when we get to a closing bracket, we have to find a matching open bracket. And the longest substring that we can basically create is dependent on whatever we have in the middle here. So if this here in the middle is a well-formed substring of parentheses, then the whole substring, the whole string containing all the additional two parentheses is also a well-formed substring. So basically, we have a problem inside of the problem. If we have a solution for the sub-problem, then we can easily check for the bigger problem and also the whole initial string. So we need a way to check if we have a well-formed substring for the sub problem, and to do that we need to have some kind of DP state. So the DP state will basically, for each index corresponding to letter, corresponding to character in the string specified by the index I, it will just declare the maximum sub length of the substring or containing only well-formed parentheses. So in the case when we have, for example, let's just say this. So these here, this string and this character here corresponds to the DP of 2 will be equal to 2 because it contains a substring of length 2 of well-formed parentheses like this. Now, when we are calculating the DP for this parentheses here, we will check whatever we have for DP I minus 1, so the previous letter. And in our case, because this is index 3, we will basically reference this. So we will have 2. And how do we now check for the opening bracket? Well, basically, we have our current index, which is 3. We can just subtract 2, which kind of cancels out these two. We just skip over these two parentheses, and then we just have to minus 1 to offset it and to find the character, the letter, basically the character before this middle substring. So in this case, we'll just get 0, which is this parenthesis, and we can easily check by indexing in the initial string if that bracket is an opening bracket, because we have an closing here, opening here, and we skipped all of these strings because they are forming. We stripped all of these characters because they are forming a well-formed parenthesis on their own. Then we know that we can update the DP of I to be equal to whatever we have at DP I minus 1, so the character, the previous bracket, plus 2, because basically we have 2 more two more brackets that create an additional longer substring. Basically, those two brackets are this closing one and this opening one. But we are not kind of done. We can have a situation where we have, for example, this, and now we have solved this subproblem because this is a subproblem here. But now we can see that the whole string is actually a well-formed parentheses substring. Because these two are just replication of this, so we know it's also well-formed. So to check the final DP of the I, we will also check whatever we have before the last the opening bracket. So if we got 0 here, then basically 0 minus 1 will be outside the boundary. But for example, this would be 1, 2, 3, and that's 4. So we'll have 4 minus 1, and that would be 3. So we will be checking whatever this bracket is doing with the rest of the brackets, kinda. So we will just do dp of 3. And dp of 3 we will have already calculated to be 4, because it will form a well-formed substring of parentheses with the remainder of the three parentheses. So in that case, we'll just add to dp of I whatever we have from the dp of 3, and for each of the dp of i's, basically we will try to update the max length, because it's quite possible that the longest substring of well-formed parentheses will not end at the last character. So we cannot just do the dp of n, for example, to return as the maximum value of basically representing the longest well-formed parentheses substring. So for each iteration, then we will just be checking if we can update the max length by comparing it to the current dpi that we have just calculated using these two formulas. And at the end, we'll just return the maximum length. And because we only need this dp, which will track each of the indices, it will be proportional to the size of the length of the string, and we will be only going over the string only once. So we will have linear time complexity as well, so both linear and time space complexity. We'll declare our n to be length of the string, and if n is smaller or equal to 1, that basically means that we cannot have a pair in brackets, so we will not be able to form a well-formed parentheses substring, so we'll just return 0 as the longest valid parentheses substring length. Then we will initialize our max length to be 0, and we'll create our dp of the same size as the length of the string, and then we'll traverse over all of the brackets that we have inside of the string s. For each bracket, we'll check if it's a closing one and if I is larger than 0, which basically means that we have enough space to have a matching pair. And then we will try to find the matching index of the matching opening bracket. And to do that, we'll just check whatever we have for the size of the longest well-formed parentheses substring ending at I minus 1. So basically at a bracket before our current bracket. And we will use that information to basically subtract that from our current index and then minus 1 to offset it and to go to the character before that valid substring. And then we will basically just check if that matching index matching bracket index is inside of the boundary of the string, and if it's a opening bracket, we can use the indexation here to index the initial string and to check if it's a open bracket. If it is, then we will just update the dpi to be basically whatever we have for storing the dpi minus 1 plus 2, because we basically just received 2 more parentheses. Other than that, we will just see if the matching index is larger than 0. So basically, there's a remainder of the brackets before it, and we will check if there's another substring, maybe similar to our current substring that we are checking, that's also well-formed parentheses substring. And to do that, we will just do the matching index minus 1. So we are checking the dp value of the bracket before our opening bracket, matching opening bracket, and we are just adding that to the dp of I. Then we'll just do the max length to check basically if we can update the max length by comparing it to the calculated dpi in this iteration. Finally, we'll just return the max length after we have iterated over all of the brackets inside of our string.